you so much, Rob. Thank you, everyone, for showing up. I know it's kind of a busy season with the Christmas stuff, so I appreciate everyone making the time to come to this conference and this talk. We do have something very exciting prepared for you today, so I hope everyone has a little bit that they take away with them so that they can make their environments that much more secure. Now, with that being said, I'll get started. My name is Dagmawi Mulugeta. I'm a threat researcher at Netskope Threat Labs, and today we're going to be talking about a specific attack technique that we refer to as Cloud C2. Awesome. So with talks like this, I typically try to have an outline so that people have an idea of where we're at and what's to come. So we're going to start with introducing what Cloud C2 is. What do we mean with this, crazy, wacky term? And we'll talk about how that's different from traditional C2. And then we'll take an offensive look into things, and then we do this by doing a deep dive into how you can simulate this in your environment and see what the controls you have in place are willing to detect. And then we'll take a defensive look into things and see why certain detection methods might have challenge detecting this technique. And then we'll move to how you can actually try to detect this using a new set of behavior signals, and that'll be this takeaway section. And then finally, we'll conclude everything by reviewing the key takeaways from all of this. Awesome. So let's get started. So what is Cloud C2, right? So before we get into Cloud C2, let's talk a little bit about what command and control is, right? So command and control, for the maybe one person that doesn't know this in here, right, is a stage in the cyber kill chain. The cyber kill chain is a set of steps an attacker uses when they compromise a target system, right? It typically starts with doing some reconnaissance. They'll then use the information they've gathered from recon to find a weakness that they'll use to generate a payload against, deliver that payload. This payload will exploit this weakness they found during this recon phase, and then that will install a particular piece of malware that'll phone back home and pull for additional commands, right? So this network communication of pulling for additional commands is what we refer to as command and control. Traditionally, this has been done via mediums like HTTPS and DNS directly to the attacker-controlled server. And if you wanted to simulate this, you could do this with Cobalt Strike and PowerShell Empire, right? So that's a quick crash course into what command and control is, right? So what is cloud command and control? So traditionally, what attackers do is they'll set up their own servers, their own domain, their own IP addresses, right? Their own infrastructure to pull these commands back and forth. And you can see this in the top right, where a compromised device is going to reach out to the attacker-controlled infrastructure to pull for commands. And this has been tough to detect, but I know the security community has done a pretty good job of using threat intelligence feeds to identify this attacker-owned infrastructure and block communication to it. So what attackers have started to do more of recently, this is actually not new, but we've seen a large uptick recently, is they started abusing cloud applications as a medium for command and control. So they're using things like DropBox folders, Google Drive, Slack channels to send these commands back and forth. So why would they want to do this? Well, firstly, it's very minimal setup, right? Same reason why most of us would want to use this, right? It's very cost efficient. Most of these apps have a free tier, so you can quickly get set up and get going for free. And it's that much tougher to detect. I mean, almost everyone has a Google account where I have the Google Drive. So if you want to blend into existing traffic, using one of these apps makes it that much more enticing as an attacker. So how often does this happen in the real world though, right? So this is a little bit of a noisy slide, so I apologize for that. But what I wanted to show are the malware samples and the cloud apps they've abused for command and control. And you can see BoxCon, Nimblebomb, and Crutch have abused Dropbox, Graphite and Blue Light have abused OneDrive, Aclip has abused Slack, we've seen GitHub abuse, Google Drive abuse, Twitter, Tumblr, Blogspot, Google Docs, Google Scripts, Pastebin, OneHub, Telegram, right? All of these apps have been abused for command and control. And this is actually a very select list. A much more detailed list can be found on MITRE's page as well. And you can see that there's really no cloud app that's immune to this. It's not, just one cloud app's problem. An attacker can use any cloud app for command and control. And they have. Cool. So that's a very quick crash course into Cloud C2 and how it's happening, right? So let's now take a closer look of how you can simulate this in your corporate environments and take an offensive look into things, right? Cool. So we're going to look at three tools primarily here, Empire, C3, and Covenant. Some of you might already know these tools. And we're going to take a look at two apps in particular, Dropbox and Slack. These are the apps that are generally more popular with attackers and individuals as well in corporate environments. So we wanted to look at those. And then for each of these apps, what we're going to do is we're going to talk about what the cloud app is meant to do. And we'll talk about why an attacker might prefer this cloud app. And then we'll go over one real world example of an abuse of this cloud app. And then for the bulk of this exercise, we're going to go through a detailed walkthrough of how you can simulate this in your, the red team engagement or a penetration test assessment. And then finally, we'll briefly look at a behind the scenes look just under the hood of how this cloud app is actually being abused for command and control. Cool. So the tools, we used a lot of tools in this research, but the three primary ones are Empire, Covenant, and C3. So Empire is a PowerShell and Python 3 post-exploitation framework. It's open source, maintained by BC Security. It's a really cool tool to kind of get set up and get going. It's a Linux-based tool. Covenant, on the other hand, is Windows-based. It's a .NET C2 framework. It's also open source, and it's also a great tool to play around with. And then the third tool we're going to use is Custom Command and Control. So this might not be as popular as the other ones, but it's actually really, really useful to test Cloud C2 specifically, because it provides a vast variety of mediums to send your commands through, and it integrates with Cobalt Strike and Covenant. So it doesn't really worry about the command execution and interpretation bit. It kind of offloads that on Cobalt Strike and Covenant. It'll just provide a vast variety of these mediums you can use. It's also maintained by F-Secure Labs, and all of these three tools are, highly recommend them to kind of get set up and get going. Cool. So let's start the deep dive with DropBox. Right, Dropbox is a cloud storage app, and like most cloud storage apps we've seen, they tend to be abused by uploading, downloading, and deleting encrypted and encoded files. This cloud app actually, provides a very flexible app development interface, and you can get set up quite quick. And as a bonus for the attacker, it exists as both an enterprise and personal cloud. So if you're going after a company that may be an enterprise level customer of Dropbox, as an attacker, you're that much more enticed to use this app for command and control. Cool. So just going over one real world example of abuse. Mole Rats, this threat actor, was found abusing Dropbox for command and control earlier this year. Now, this threat actor is known for being stealthy, and they've used this technique before of abusing cloud apps. But what was interesting in this case was they were using multiple accounts for communication. So you can see an attack flow here where a malicious Office document gets downloaded, that downloads and executes a PowerShell command line, that downloads a .NET backdoor, right, that was reaching out to the attacker via multiple Dropbox accounts. Right, and they were separating responsibilities out through these accounts. So they were using one for, command and control, another for file exfiltration, and then a different one for backup C2. And they were doing this for resilience, right? So if one of these accounts gets burned, they have other ways of communicating to the compromised machines. So how can you simulate this? You can do this using a variety of open source tools, Dropbox, C2, C3, or Empire. We're going to use Empire here, but that's somewhat arbitrary. You can really do this with any of the other tools. We're going to follow a 4-step process, right? We're going to create the account. We're going to set up the Empire listener with the access token from the account. We're going to generate the payload and deliver that directly to the victim. Now, normally with this step, what you'd want to do is you maybe want to simulate, you want to have like a phishing campaign that compromises that a victim will fall victim to, right? And they'll download a malicious Office document, then this is the next stage payload. But for the sake of brevity, we're just going to directly just compromise the machine, just simulate a compromise and go from there. And then once we have everything set up, we're going to interact with the compromised device by tunneling commands through the Dropbox account. So the full attack flow will kind of look like the following, where the Empire server is going to upload commands to Dropbox. The malicious process or the agent on the victim is going to pull those commands down, execute them, upload the results back to Dropbox, and then the Empire console is going to pull that down. Cool. So first things first, we're going to create the attacker control Dropbox with the access token. So we've signed up for Dropbox here, and we've created an app, named it Empire C2, and we're going to give it full read and write permissions to this account. And this is free, right? It took maybe like 3 minutes to do this. And then what we're going to do is we're going to set up the Empire listener here. So we've downloaded and installed Empire. We've configured a Dropbox listener here with all of these configurations, and we're going to pass it the API token from the previous step. And if we've configured everything correctly, when we type execute, you can see that the Dropbox listener has successfully started. And what this does actually in our account is the following, right? So it's going to go in and create this Empire folder. Now, this is doesn't have to be Empire. You can change this. We just stuck with the default name, but it's going to go ahead and create this Empire folder and then 3 subfolders underneath it, like results, staging, and taskings, right? So you can kind of see it's kind of laying the foundation here for that communication that's about to happen. And then we're going to go ahead and generate a payload and deliver that directly to the victim, right? So we're going to, on the attacker side, set the listener to Dropbox, download this, create this Windows batch file, copy that to the victim and run it. You should see this PowerShell process start up. And then on the attacker side, you'll see an agent check-in, right? And this will have details like the agent ID, the language it's running as, which is PowerShell, the IP address, the username, process ID, the delay and jitter, the last time it was seen, and most importantly here, the medium it's communicating through, which is Dropbox. Cool. So let's see a quick demo of what this looks like. This works. Okay. So this is on the victim side. You can see we have this batch file. We're going to run it as administrator because why not? And you can see this PowerShell process start up. And then on the attacker console, you can see it just takes a few seconds to get fully set up, but you can see this agent has checked in. It is a multi-stage deployment, so you do need to wait a few more seconds for it to get fully set up. But yeah, that's why these are blank. It just needs one more second. Awesome. So you see now we have all those details we saw in the previous slide, right? And we're going to go ahead and interact with this, and we're going to ask it to run 2 commands, who am I, and a list of the processes that are running. While this does take a second to kind of fully propagate, we can go ahead and look at the Dropbox account to see what that communication looks like. You can see it's sending these commands back and forth through these text files, right? And the name of these files is the name of the agent. So that's kind of how it's managing its bookkeeping internally. So if you go back to the attacker console, it does take a while to get fully set up, but that kind of happened quickly. So you see a list of the processes here, right? The process ID, the username, etc. So if we take a look at the victim side, we're going to look at this tool called Fiddler. So Fiddler is a debugging proxy we've used to look at the communication going outbound. If you take a look at what's happening from this PowerShell process, you can see it's trying to grab details around this file, right? And if we try to see what the contents of those files are when it tries to download it, now you see that the data is kind of gibberish, right? It's encrypted and encoded. You can't make sense of it at this stage, at least in the middle. Cool. Do that again. Awesome. So we just looked at how this communication is happening, right? We saw it was through these text files that were being uploaded and downloaded. If we try to look at the content of one of these text files, we can't really make sense of it, and that's because it's encrypted, right? You can look at the routine and the code that's actually doing that as well. So I know that was kind of quick, but let's quickly summarize what we just saw for Dropbox. It's a cloud storage app that's abused by uploading, downloading, deleting these encrypted files. If you wanted to simulate this, you can using Dropbox C2, C3, or Empire. And depending on maybe the sophistication level you're trying to model, you can do a few different things, right? You can, if you're trying to model not very sophisticated threat actor, you could use the default configs. If you want to model a sophisticated threat actor, you could customize the configs a little bit. And if you want to model a very sophisticated threat actor, you could do like what we saw in the example, which is use multiple accounts to send commands back and forth so that responsibilities are segregated. Awesome. So let's do one more deep dive with Slack. So Slack, again, I think most people are familiar with it, but in case you're not, it's a collaboration app and it's useful for sending messages internally within an org. And attackers tend to abuse this by creating channels, sending messages, or reading and writing to messages, so replying to messages. This also exists as an enterprise and personal cloud, which further enables an attacker to want to use this, right? Going over one real world example. So this is, malware sample named AClip was abusing Slack for C2, I think a year ago now. And it was targeting an airline to steal reservation data. And you can see in the attack flow on the right side, what was interesting about this is they are using different channels for communication. So they're using Slack's features to kind of make their lives easier as well, right? So they're using one channel to send system information upon compromise, a different channel for sending commands back and forth, and then a third one to send the results of these commands as well as any files that might have been requested, right? So they're kind of really getting the most from this subscription from Slack. Cool. So if we do the same thing we did with Dropbox, we can simulate this with Slack or Slack C2 bot or Slack shell. We just used C3 Covenant because they have a very detailed set of steps that we could use. Again, we're going to use a 4-step process here. We're going to sign up for the account, create, set up C3 and Covenant with the Slack account that we set up. Then we're going to generate a payload and move that to the victim machine, and then we're going to interact with the compromised device by tunneling commands through Slack, right? So first things first, we sign up for the Slack account, create a set of application credentials that we want to use. Then we're going to use these credentials to set up C3 and Covenant. And you can see C3 has this nice graphical interface that you could use. We're going to go ahead and set up a Slack channel. We're going to give it the token or the credentials that we created. And if we set up everything correctly, you should see a graph like on the bottom right side where you have the gateway, and that's communicating out through that channel. One thing to note if you do this is C3 and Covenant are two different repos, so we had some issues with integrating them. That commit hash works the best for us, so just something to make a note of if you do end up going through this exercise. So what this does, similar to how we saw that Empire directory being created in Dropbox, is this is going to go ahead and create a Slack channel for us to use, right? So this 6EEP channel gets created, and we see this C3 bot joins that Slack channel. So it's kind of setting that groundwork for that communication, right? So what we're going to do at this point is we're going to generate this payload that has a Slack token. It's all auto-generated. We're going to download this payload that's called a relay in C3. We're going to copy that relay over to our victim machine and run it as admin. Cool. So what this does is once we have fully set up, we can see on the right side, this is going to create that whole attack flow where we have the gateway. It's communicating through channels to the victim machine on the right side. And we have Covenant set up with the whole thing. So we can run commands like who am I and get the current directory. And that'll kind of flow through Slack all the way to the victim, get executed, and then come back to the gateway and show up on our console, right? The results will show up on our console. So if we take a look at quick video of this, we can request the processes here, and you can see the request getting written out to the Slack channel. The victim is going to download all that stuff and delete it, and then upload the results here, and then the attacker is going to download and delete it and show it in their console. So if we just take a look at that one more time, that was kind of quick. We ask for a list of the processes here from the attacker side, and then the Slack channel that request gets written out really quickly. Right, it's encrypted and encoded. You can't really make sense of it here. And then the results get written back, gets deleted, and then shows up in the attacker console. Cool. Again, that was very quick, but just to summarize everything we talked about, collaboration. Slack is a collaboration app that's abused by sending commands through Slack channels. If you wanted to simulate a threat actor doing this, you could do this using tools like C3 and Covenant. And depending on the sophistication level you want to model, you could do a few different things for this as well. Awesome. So let's talk about the fun stuff, right? Defenses. So what can you do to defend this? But before you get into that, why can't my existing C2 controls just detect this in the first place, right? Why do we have to introduce this whole new Cloud C2 concept? So here is a screen cap from Fiddler. So we had two different processes running here. The first is the GitHub desktop application that's valid executable from GitHub that we downloaded and installed. The second was a malicious process from C3 called a relay that was abusing GitHub for command and control. right? You can see in both of these cases, the malicious and benign case, right? The traffic is going to the same domain. It's api.github.com, right? The domain is a valid cloud provider domain, and the traffic is encrypted the same way using the cloud provider certificate, right? So if you have an IP or domain-based block list here, that's not going to work because all of this is going to GitHub servers. Unless no one in your org uses GitHub, you definitely don't want to block list GitHub servers, right? So you need a different kind of approach to detect this particular type of C2. So before we get into how we're going to detect this, I just want to give you a quick layout of what our typical victim machine looks like. So we had the following 3 types of processes running. So we had benign processes like browsers, your Chromes and your Firefoxes, etc. Those were installed and running. We also had these native apps that we call sync clients installed as well. So these are like the Slack app itself, the GitHub app itself from the website, right? These were installed and running as well. And we had people using them like how they would normally. And then we also had some malicious processes running. So these are like C3 payloads, Empire payloads that are used to generate this malicious Cloud C2 traffic. Those are installed as well. And all of this traffic was flowing through Fiddler, and we used Fiddler to log that data, export it out as a .scz file for analysis. All right, this is what a typical victim looks like, right? Cool. So what does our detection logic look like at this point? So from our victim machine, we had this traffic that we call inline traffic, right? And we had this inline traffic coming out of this victim machine going to the internet, and we wanted to extract a set of signals, right? These signals can be categorized into 5 groups. The first were signals that tell you about beaconing that might be present in the traffic. Second are any anomalous behavior that might be different from the baseline you've come to understand for the user or the org. The third is the content. What's the nature of the content that's flowing? Is it encrypted or encoded in any way? The fourth is host access patterns. Do we see any host access pattern that closely relates Cloud C2 type of behavior? And then lastly, are sequences. Are there any sequences here that we identify with C2 that's abusing cloud apps, right? We're going to extract those signals from that inline traffic and then feed it to this decision component that's then going to say, is this benign cloud traffic, in which case it's allowed, that's fine, or is it malicious Cloud C2 traffic, in which case it's blocked, right? So we're going to look at the traffic, extract a set of signals that we're going to use to decide, is this okay to let to the internet or not, right? Cool. So what are these signals that we just briefly talked about, right? So the first set of signals give us information around beaconing. So here we have 2 screen caps in this slide. The top is Empire abusing DropBox for command and control, and then the bottom is C3 abusing GitHub. So in both of these, 2 different tools, 2 different cloud apps. And we can see in both of these cases that there were frequent checks to the same URL, right? It's iterative at a regular time interval, just checking. We see it's a repeated request and a response. So it's a 409 on a GET request at the top, and then it's a 200 on a GET request at the bottom, right? We can see it's an unusual process making this request. It's not the browser or the sync client, it's something else. And there's not much deviation in the data that's being sent back and forth, right? And we're going to extract these features or these signals, and that's going to give us information around whether a process is beaconing from a system. Now, one thing to note, I should have done this earlier, none of these tell us, and none of these are the silver bullet. Like none of this by itself is going to tell us this is Cloud C2, right? We're going to use these signals to make an educated decision as to whether this might be Cloud C2 or not, right? So that's what we're going through here. The second set of signals are anomalousness signals. So this is going to give us information around whether, there might be deviations from what we understand the baseline to be for this particular user. So the first set of signals are unusual cloud entities. So things like Slack channels, GitHub repos, Dropbox folders, etc., right? A different set of cloud entities than what this user typically accesses. The second is an unusual user agent, or, even worse, if the user agent is associated with a known malware, right? If typically what malware authors will do, they'll find a, popular user agent at a given moment and use that as part of their communication flow. That might be different from what a normal user uses, and if that's the case, we want to flag that as well. The third is if there's an unusual username that's being used to log into the app. So typically in a corporate environment, a user has a handful of these usernames that they use to log in. If you see a new username pop up, that's something you want to flag as well. And then lastly is if there's an unusual authentication method. So typically in corporate environments, for these SaaS apps, they'll use like an SSO solution like Okta to log into everything. Right now, if you see like a token being used to communicate to GitHub or something, we want to flag that too. Awesome. So the third is content, right? We saw earlier, I think a few times, is if the data is encrypted or encoded, that's something we want to make a note of. And you can see on the right side that the attacker is using GitHub to communicate, and it's encrypting and encoding these task files and committing them to the repo. The victim's going to download that and upload its own encrypted and encoded results, right? Same thing for Dropbox as well. These text files contain encrypted and encoded data, right? So if we see that, we want to make a note of that too. The fourth set of features we actually got from F-Secure's blog. They have a really nice blog of how to detect C3 specifically, so I highly recommend looking at that. But what they made a note of is first, if no one uses Slack and you see communication to slack.com, obviously that's a giveaway, right? But let's say you are using Slack, you see that the actual Slack executable communicates to a different set of hosts than malicious process that's just using Slack. The actual Slack executable reaches out to a variety of other hosts to grab CSS, to grab avatars, to grab GIFs, etc. But malware process that's abusing Slack really only reaches out to a handful of things. It's slack.com and files.slack.com. So if you see a difference in this deviation, we want to make a note of that as well, because that may be indicative of something that's just abusing Slack's API for communication. Next up is sequences. Before I dive into sequences, we also want to flag any known hard-coded endpoints. So again, we just don't want to alert just on this, but if we see communication to endpoints we know are hard-coded in these tools, or these, what malware typically reaches out to, we want to see if there's any spikes in these, right? So if we see that one day suddenly users reaching out to the Dropbox download API, 500 times more than normal, that's something we want to make a note of as well. And we also want to see sequences, right? Like how we saw in the beginning on the offensive side, typically communication is a download from Dropbox, right? A delete from Dropbox and then upload to Dropbox. If we see this over and over again, right, that's not really a human interacting with Dropbox. It's more of like a robot, right? So if we see that, we want to flag that too. Cool. So I know we just covered a bunch of these signals. For our POC that's kind of starting at this point, we're going to use a select list of these signals to help us identify Cloud C2. And this select list is on this slide, right? If we see a low number of domains that are being communicated to, if there's a low number of referred traffic, so malicious traffic or C2 traffic generally isn't referred. If we see a set of known Cloud C2 domains that are being contacted, if the data is encrypted or encoded in any way, right? If there's not much deviation between requests, right? So if it's every 5 seconds, if you see a beacon go out, if there's an unusual authentication method, unusual user agent, unusual cloud repo, unusual username, Slack channel, apps, or bots, we want to flag these as well. And we're going to use this. We're going to use this and send this to the decision component. Now, this is an area that's still in research, but for the sake of just completing the process and seeing if it works, we created our own decision component that just says if the traffic from one process to one domain contains more than 5 of these signals, we want to raise an alert, right? So that's just a simple check at this point. Ideally, we want something a little bit more robust, something that's a little bit more statistical. But for the sake of just doing the POC, we just went with that particular detection. So just revisiting what we're going to do one more time. We have these victim machines that have benign and malicious processes running, right? We're going to extract that traffic. From that traffic, we're going to extract a set of signals that we're going to pass to this decision component. And if more than 5 of these signals are present, we're going to raise an alert, right? Cool. So let's go over a quick demo of how these signals look. So first is Empire using Dropbox like we saw. So Empire, this is what the attack flow looks like. So the Empire console is going to upload commands to the attacker-controlled Dropbox account. The agent that's running on the victim is going to pull those commands down, execute them, upload the results to Dropbox, and then the Empire server is going to pull those results down and show them, right? So we ran this traffic for about a day and a half on this victim's machine. We extracted that data and we want to take a look at what these signals might show us, right? So if we take a look at that, so here we have that .saz file that we exported, and we're going to just do what we said, right? We're going to extract those signals, see if there's anything useful there. It is a day and a half worth of data, so it does take a few seconds to fully process. Yeah, so we have about 4,000 sessions here. A session is one process communicating out to one domain. You can see most of this is the browser communicating out to a large variety of these domains. But we see we flagged one process communicating to one domain as likely Cloud C2. And we want to dive into that a little bit more to see what the indicators were. Cool. So if we saw this PowerShell process communicating to content.dropboxapi.com, and that was flagged as likely Cloud C2, right? And why was this? We saw, or it's telling us that it's because it sent 865 requests to only 2 domains. None of this traffic was referred. The authentication method being used here was a bearer token, right? The content was encrypted. Their time interval between requests was 2 seconds with almost no deviation, right? The user agent was unusual for this user, which is actually a default for Empire. And it sent requests to 2 known domains associated with Cloud C2. And because of this, we flagged this as likely Cloud C2 traffic, right? And if we repeat the process for GitHub and C3, you can see we just used a different cloud app and a different tool. We flagged 2 instances in this case, both the relay communicating out to api.github.com, and then the second one is raw githubusercontent.com, right? So 2 different domains. In both of these cases, it's a large number of requests to only 2 domains. None of this traffic was referred, right? It was a token that was being used for communication. The content was base 64 encoded. The time interval between requests was 5 seconds. I know you can't see it probably from far behind. The time interval was 5 seconds with 2 second standard deviation. There was communication with unusual repositories here, and you can see that it reached out to a vast variety of these cloud repos, and it was actually also using an unusual username to talk to these cloud repos, right? In this case, it's like insider threat 648 or something, right? And it's a similar set of signals for the second domain as well. And then we can repeat this process for Slack and C3 as well. You can see large number of requests to only 2 domains, no refer, bearer token. The content was encrypted and encoded. The time interval was 5 seconds with 2 second deviation. There was unusual usernames that were being used to communicate out to Slack, unusual Slack channels. So you can see that 6EEP Slack channel was there as well. The hacking channel. Communication with unusual apps, unusual bots. The C3 bot was there, and it reached out to 7 known endpoints associated with Cloud C2. And because of this, we flagged this as likely Cloud C2 traffic. Awesome. So, hope that was, a little bit early. Awesome. So, we covered a whole lot, but just going back to the beginning, just concluding, all the points that we hit on, we started by asking what is Cloud C2. We saw that it's command and control that abuses cloud apps, right? And we saw that, which apps are abused for Cloud C2. We saw a vast majority of them can be abused. We saw how you can simulate this in your traffic. We can use Empire and C3 in a 4-step process to, quickly get this set up and test for Cloud C2. And then we went over why this is hard to detect, and it's because the traffic is going to the valid cloud provider server. And then we talked about what defenses we can put in place, and we saw that we can use a set of behavior signals to identify Cloud C2 traffic. Awesome. So I'll be happy to take questions in just a second, but in case I don't get to it, or you'd like to stay connected, my Twitter handle is @Dagmawi. My LinkedIn is Mulugeta, and we'll have a bunch of updates on this and future cloud application research on our blog, so please do give that a follow. Outside of that, I'll be happy to take any questions if anybody has them.
Thank you.
Hi. In terms of frameworks and detection environments, is there any open source, or is this all proprietary rule-based frameworks around?
For the attack or the detection?
No, detection.
Oh, the detection. So we weren't planning.
Could you use the microphone again, please?
Sorry?
The microphone.
Oh, sorry. So the question, if I understood it correctly, is for the detection aspect, are there any plans of or open sourcing, or are there any available open source tools for this? So we weren't actually planning on it, but we've gotten that question so much that's making me wonder if I should go back and clean this up and release this so that people have access to it. So yeah, maybe I will. Yeah, great question.
Hey, thank you for that. It was really interesting.
Where are you? Sorry. There you are. Okay.
I guess, whose problem do you think this is? For example, should Slack be scanning their customers and go, oh, we think you're using us to do Cloud C2, or do you think they should kind of step back and say this isn't our responsibility?
Yeah, that's a great question. I think that's probably the first question I got from my research team when I brought this up with them. So yes, it's definitely both people's responsibility, and I say that because the cloud providers are actually doing their best to kind of detect this. So F-Secure, the team that wrote C3, they actually wrote a blog about how Microsoft is making it harder for them to abuse these apps, and that's because they're kind of being proactive. But if you take a look at it from their side of things, it's really just what they see is these files getting uploaded and downloaded. So they can't really tell what the content is or if it's being malicious in any way, right? It's only when someone reports it, they can be proactive and take it down, or reactive and take it down, right? So they try to do their part, but at some point you have to realize, oh, okay, this is something I need to do. I need to be better at on my end as well as a defender. So I would say it's kind of both. Yeah. Okay.
Hi, thanks for your talk. During the course of your research, did you see any evidence of people trying to hide the C2 communications, say in Slack, just by encoding them as innocuous chat about the weather or anything like that?
Yeah, so not often, but we did see it. So there was one example where we saw a person was abusing YouTube comments to send C2, and they were saying, oh, my keyboard doesn't work. And then it was gibberish after, but it was actually encoded commands they wanted people to execute, right? So they kind of get clever with it. Typically, especially for a low, maybe moderately sophisticated actor, not that often. But if someone really, really wants to evade that kind of stuff, they can. You can still use some of these signals against them in that case. So I guess my answer is you do see it sometimes, but it still works to use these signals for the vast majority of attacks that we see.
Thank you very much for the talk. One question was, when you saw this being abused in the wild, was this Cloud C2 often the first initial access? Or were they trying with a traditional C2, for example, to be able to get the initial access and then dump the processes and see what's on the box before they tried to blend in with that traffic? Or do they do that kind of front heavy on the recon before they even attempt to get that?
So we've seen a little bit of both, I would say. I'm trying to think how it was, but typically the initial delivery is not, we see it from like, a Google Drive folder or something like that, but there's still like EDR solutions and traditional approaches to detect that. But once they've set up Cloud C2, that's when it gets a little bit more challenging. And that's when we started thinking about this. The initial deployment, we haven't really looked at too much in depth. So I would say it's maybe 50-50, but I'll have to go back and check just to be sure. That's a great question, by the way.
Hi there.
Yeah.
Thanks for the talk. Really interesting. I want to ask, so the whole point of being cloud is that you send like the commands through the Slack channels, right?
Commands.
For example, the Slack channel.
Mm-hmm.
Where is the Empire server, for example, sitting? Would it be cloud as well, or would it be like on the attacker's side?
So the Empire Dropbox configuration specifically, right? The Empire would be it would be separate, right? It wouldn't be running in the cloud; it'd just be abusing the cloud. Sorry, let me understand your question. So you asked with the attack setup specifically, is the Empire listener is that running also in the cloud?
Yeah.
I mean, you can run it like on an AWS server or something, but it doesn't necessarily have to be in the cloud, right? It just that first interaction from the victim side is where you want the cloud to be. After that, you can even chain that with using like traditional C2, which attackers generally do is they'll use like, their normal server. And then at the front of that, they'll have like a DropBox account or Slack account. So they have like multiple stages before it gets to them, just to be that much more resilient. Yeah.
Thank you. Do you have any more questions? One more at the back.
Thank you for the talk. You were talking about the communications between them being encrypted. Did you look into what sort of encryption scheme they were using? Were we using anything particularly strong?
Yeah, so we did not. We just tried to see if the content was encrypted or not, but that is an area we're trying to look into a little bit more. So the next phase of this that we're doing, just like a slight preview for people, is exfiltration. And with that, we're doing a very deep dive into like how the content is encrypted, what kind of encryption works, if maybe encryption and encoding, and then another level of encryption or something like that would work better, that kind of stuff. So right now we just saw if the content was encrypted or not. Yeah. Great question.
If there's no more questions, Dagmawi, thank you very much.
Awesome. I'll be hovering around, so if anybody has any more, I'll be happy to answer them.
That's great. Thank you all.